Welcome back to the next video lecture on diagrammatical presentation. So far we are discussing about a diagrammatic as well as graphical presentation. So in this video lecture we'll discuss about first one-dimensional diagrams. Alright. So in this video lecture we'll discuss about one-dimensional diagram. In that, one of the famous one-dimensional diagram is bar diagram. One of the famous one-dimensional diagram is bar diagram, right? So bars are means what? I mean, bar diagram means what? Bar diagrams are nothing but it is a type of diagram which contains bars exactly like this, right? Exactly bars like this, right? Or you may observe like this bar also, right? Any kind of bar. Usually bar means what? Like this is what the bar, right? So here bar diagrams are one-dimensional diagrams because only one dimension of the bar is taken into consideration. That is length of the bar, right? Whatever this is the length of the bar, see, this length of the bar is considered, right? Taken into consideration, but not width. We are not considering this width. We are not considering this width. Just we are considering only length of the bars. And that length is, whatever we are considering this length of that bar to represent the data, that length is either equal to the given data, or proportionally equal to given data, either equal to given data or proportional to given data, right? This is the first point. And the next point is the width, whatever we are considering this width, or this width, only for attraction purpose, right? Only for attraction purpose, we are considering that width of the bar, right? So see, this is bar and this kind of bar, right? When compared with these two, first and second, the second one looks good, right? Because the width is little bit more than the first one, right? So likewise, attraction is considered only, sorry, that width is considered only for attraction purpose. Then, while drawing bar diagrams, we need to consider, sorry, we need to consider, uh, just wait. Okay. So, while drawing bars, we need to consider 2 points. I mean, we need to consider as a rule or as a mandatory rule, we need to consider 2 points. That one point is the width of the bar, right? The breadth or width of the bar. Say, for example, suppose I'm drawing the bar here. Suppose I'm drawing the bar here, right? So, whatever I width consider, that width is same or that width remains uniform for entire set of the bars. That width or that breadth, right? So this line or this uh, area, it should be same. See, this is the first point. The width or the breadth of the bar should be uniform throughout the entire system, and the gap between each bar should be equal. This gap between each bar should be equal. So we need to follow these two rules while drawing bar diagrams. Then we have types of bar diagrams. Totally, we have 4 types of bar diagrams. One is simple bar diagram. One more is, I mean, second one, component bar diagram. Third one, multiple bar diagram. And fourth one, percentage bar diagram. So now we'll discuss in detail with examples of these bar diagrams. I mean, types of bar diagrams, simple bar diagram as well as component bar diagram, multiple bar diagram, and percentage bar diagram. So first, we'll start with the simple bar diagram, right? So simple bar diagrams are used to represent only one variable, right? Simple bar diagrams are used to represent only one variable. For example, population of any country, sales of any company, or sales of any country, or whatever, sales of any business institute, then production, exports, imports, etc. Right? So the bars can be drawn both vertically and horizontally. It means that we can draw the bars like this. This is what vertically, and this is what horizontally. Right? This is what horizontally. So we can draw vertically as well as horizontally, but usually vertical bars are used. Usually we have this type of bars in practice, right? So why we need simple bar diagram? Simple bar diagram used to represent only one variable. So now we have one example for this simple bar diagram. Now we are going to uh, now we are going to solve that example, right? Uh, so now we are going to solve that example. See what they given. Construct simple bar diagram. Construct simple bar diagram for the following data related to COVID positive patients or COVID positive cases found January to June in the year 2020. It means that month-wise they given the data, right? Month-wise they given the data from uh, June to, sorry, January to June of the year 2020. They given. What is that data set is there? Their data set is related to COVID positive cases found in a certain region, or in a certain place, or in a certain country, or in a certain states. It may be anything, right? Then here, what are they given in the January according to that given data? In the January, they found 1600 cases. In February, they found 2000 cases. In March, 2200 cases. In April, 2500 cases. In May, 3000 cases. And June, 2100 cases, right? So now we are going to represent with the simple bar diagram. So before drawing the bar, or sorry, not bar diagram, in generally diagrams or graphs, we need to follow certain set of rules. What are those rules? The first rule, the rule number one, it should be given by the title. We need to consider the scale. Third one is neatness. Fourth one is simplicity. And the fifth one is index and footnote. We need to follow these 5 rules while constructing whatever it may be, diagram as well as graphs. Right. So here I will consider the first 2 axes. Mm, okay. So first we'll consider the 2 axes. Uh, okay. Now I will consider here. Okay. Okay. X-axis. Sorry, this is what X-axis, and this is what Y-axis. So here I consider 2 axes. So along y-axis, I used to consider the here positive cases, and along x-axis we consider the months. Right. So before that, we should do the title. So what is the title? A representation of. I will change that color. I'll give the title. Don't no need to write the title. I mean the word title, but you should give the title. A representation of COVID positive cases using simple bar diagram. This is what the title, and this is okay. This is clear. Now scale. I need to consider the scale. So I used to write here scale. scale. Usually we used to write here, but because of uncomfortable in the space here, I am going to write here. So along x-axis, along x-axis, so I will consider the scale 1 centimeter equal to 1 month, right? Along x-axis, 1 centimeter equal to 1 month. Then along the y-axis, along y-axis, I will consider 1 centimeter equal to here minimum is 1600, maximum is 300. It means that 1600 to 300 I used to uh, give the data, right? So 300 means I used to consider 1 centimeter equal to um, we could consider three 30 or 300. Okay, I will consider 300 cases. 1 centimeter equal to 300 cases, right? So from here to here, let us assume 1 centimeter means 300 cases. This is what scaling: 600, 900, 1200, 1500, 1800, 2100, 2004, 2700, and here 3000, right? So along the x-axis, what I given? Along x-axis, 1 centimeter equal to 1 month. Let us assume, I mean, the gap between each month is 1 centimeter. Let us assume. So for January, we have 1600, right? So January 1600, wherever, let's suppose this is 1600. So we need to draw a bar. Let us assume this is a straight line. This is for January. Then for February 2000, right? So what I given? Along x-axis 1 centimeter is 1 month. So the gap between each month is 1 centimeter. For February, we have 2000 cases. For February, we have, let us assume this is a straight line, right? So it is a, on board, it is very, to draw a straight line, it is very uncomfortable here. This is for Feb. Okay, so here, next for March 2200. Somewhere we are 2100. So here 2200. We need to draw a bar. This is for March. Then for April 2500. 2500 for April. Next for May, it is 3000. Somewhere 3000 exists here. So this is what 3000. Then for June 2100. For June, it is 2100. Right? Likewise, we used to draw a simple bar diagram, right? So neatness is, but it is not neatness. Let us assume it's neatness and simplicity. Index is here only one variable, so no need of index. Here there is only one variable, so no need of index. And footnote. What we are going to footnote? See here. For January, it is 1600. For Feb, 2000. For March, 2200. For April, and this is about May, this is about June. For April 2500, so May 3000, and again June it is reduced. So what you are going to do, the footnote, under footnote we can give that in the month of June, in the month of June, positive cases were decreased. Yes or no? From here to here, it is increased, then it is decreased. So under footnote, we can use the conclusion that in the month of June, positive cases were decreased, right? So this is what the concept of simple bar diagram. I hope it is clear, simple bar diagram. So now we will move to the next topic that is uh, multiple bar diagram. So simple bar diagram means what? To represent only one variable, we are, I mean, to represent only one variable, we are considering the simple bar diagram. But in multiple bar diagram, the name only says multiple bar diagram. In multiple bars, diagrams, sorry, multiple bars, diagrams, two or more set of interrelated multiple bar diagrams are used to represent interrelated interrelated data or correlated data or correlated data. Interrelated data or correlated data means what? A dependent data. Dependent, right? Dependent data. To represent the dependent data, we are using multiple bar diagrams, right? So then how we are going to how we are going to draw the multiple bar diagram? As usual, consider the two scales, x-axis and y-axis. Then suppose one variable like this. This is what one variable. Next, one more variable means here bars are adjacent to each other, right? So here bars are adjacent to each other, and these different bars are denoted by some different colors. Say, for example, first one denoted by cross mark, second one I will kept empty, third one positive, right? So here I will give the index. Index means what? This is what index. Cross represents variable one, empty represents variable two, then positive sign represents variable 3. Is it clear? So this is what multiple bar diagram. The name only says why we need multiple bar diagram, because to represent two or more, see here, two or more set of interrelated data. What I given here? Interrelated data. Interrelated data means what? Correlated data. Say for example, imports and exports. Is it clear? Then in medical field or in biostatistics field, pulse rate and heartbeat. These are interrelated variables. To represent such interrelated variables or to represent such a dependent variable, we require multiple bar diagram. So now we will solve one example related to multiple bar diagram. So here what they given? Represent the data by multiple bar diagram. They given year-wise data about the diseases. So in the year 2015, the number of people affected by disease 1 is 30. In the year 2015 only, the number of people affected by disease 2, different kind of disease is 25. Next 15. Likewise, they given the data. So now first I will give the title, right? So representation now. Representation of people affected by a different disease. People affected by different disease from 2015 to 2019 by using which one? Multiple bar diagram. This is what title. Then considering the scale, second step. All right. So now here, so I will consider again as usual two axes. One is y axis, one is x axis. Right. One is y axis and one is x axis. So along x axis, what we are going to consider? Number of. Okay, I need some space here. So along the y-axis, we consider number of people, right? Okay, now what is the minimum? Okay, minimum is 11, but maximum is 60. It means that we need to represent up to 60. For that, we need to consider the scale. So scale. along scale along scale. I will write scale here. So along x-axis, I will consider 1 centimeter equal to 1 year. It means that the gap between each set of bars is 1 centimeter. Then along y-axis, 1 centimeter equal to 5 patients or 5 people. It means that 5, 10, 15, 20, 25, 30, 35, 40, 45. So like that, it will goes up to 60. It will goes up to 50, 55, and 60. Right. Okay, now, okay. So along the x-axis, what to consider 1 centimeter equal to 1 year. It means that set of bars we need to draw. Okay, this is one. First one is 30. So this is one. First one is 30. Next, this is 25. From here we have 25. Then this is 3 is 15. Right. So I will to denote this is one. I will kept empty. Empty means what? This is one. This is one. Then I will use wrong sign. I mean that cross sign. This is what indexing. Indexing means what? Denoted by different shades. It means that this is 2. Then I will use minus to denote this is 3. This is 3. So this is for the year 2015 I solved. See, this is 1, this is 2, this is 3 are interrelated. So that's why I represented in same setup. This is a multiple bar diagram. Then for 2016, this is 140. This is 1, it is 40. This is 2, 20. Then this is 3, 17. This is 3, it is 17. This is 140. This is 2, 20. This is 3, 17. Right. So this is 1 represented by empty. This is 2 represented by cross sign. Then minus sign. This is for 2016. Likewise, you need to draw for 2018, 2019, and 2017, 18, 19. For 17, I will also show. That is first one is 45. 45. Next one is 28. Here we have 28. Next is 22. So here cross sign. Minus sign. 2017. Next for 18, 50. Next 30. Next is 25. So first 2018. This is one kept empty. Then cross sign. then so in this way, you need to draw for the year 2019 also. This is what multiple bar diagram. I hope it is clear about simple bar diagram as well as multiple bar diagram, right? So very simple. First one we discussed about the bar diagram. That is what bar diagrams are nothing but we consider bars like this. After that, we have four types of bar diagram: simple bar diagram, component bar diagram, multiple bar diagram, and percentage bar diagram. So in simple bar diagram, we have, we to represent only one variable, we need simple bar diagram. Then this is what example of simple bar diagram. Then for to represent two or more than two interrelated variable, we require multiple bar diagram. In multiple bar diagram, here in this example, we denoted three variables. What are those three variables? This is one, this is two, this is three, right? So this is one represented by empty. This is what indexing. This is two in denoted by cross, X mark. Then this is three represented by minus. So this is what the indexing, and this is what scaling. To look it is simplicity and neatness as usual. This is a title, right? So here we represented 2015, 2018 of 4 years. So due to space, I didn't represent it 2019, but we need to represent. We need to represent, right? We need to represent this 2019 also here, right? So this is what multiple bar diagram. I hope it is clear. Simple bar diagram, multiple bar diagram. Next class we discuss about component as well as percentage bar diagrams.